Well, welcome to this video, and I hope you like it. If you do, click the like button, hit subscribe, and share with a friend. Okay, little talk today about the carbon cycle. And this is tied into global warming, but it's tied into a lot of other things too. It's just one of the systems occurring in nature. It's kind of a complex system. It's also kind of tied into other systems. But for simplicity, I'll kind of deal with it by itself. Sometimes they divide it into a fast carbon cycle and a slow carbon cycle. The slow carbon cycle basically starts, well, starting point's actually rather arbitrary because it's a cycle, it goes in a circle, but we'll start with just carbon in the atmosphere. Usually it's in the form of carbon dioxide. That's the most common thing out there. At any rate, carbon dioxide, when it mixes with water, forms a mild acid. Don't want to get too much into the chemistry. Basically, when it mixes with water, the water binds with the carbon, releasing a free hydrogen ion, which is what acidity is. pH is shorthand for parts per million hydrogen ions, actually. So, but at any rate, it forms carbonic acid, which is the same thing they put in soft drinks, like Coca-Cola, Mountain Dew, whatever. The thing that makes it fizzy is actually carbonic acid. Take a look on the label, you'll see that, because whenever the pressure is released, it makes little bubbles of carbon dioxide, which is the fizziness. Yeast will also do this. That's what makes bread rise. That's what makes beer fizzy. So, but getting off track there, the carbonic acid, when water in the atmosphere mixes with the CO2, there'll be a little bit of that carbonic acid, just a slight amount in rainwater. Not enough to really make it acidic as the so-called acid rain that happens in really polluted areas. So I don't want to mix up the two, but there's always naturally just a slight bit of acidity, a pH just a little bit lower than 7 in rainwater. And this acidity tends to leach minerals out of rock. And as this all washes into the ocean, which is usually where they talk about it happening out in the ocean, but it also happens in rivers and lakes, you'll get a formation of carbonate. Carbonate is what makes hardness in water, basically. Calcium carbonate. So calcium and other ions will mix with the carbonate and lock up carbon that way and become limestone. Usually there is animal life involved in between. Clams, mussels, snails, little diatoms. Don't want to say shellfish in general, because crustaceans like crabs and lobsters have a different type of shell made out of chitin. But most of your things you think of as seashells, those type of animals, whether they live in fresh water or ocean water, are making their shells out of calcium carbonate. And then as they die, this builds up in the soil and becomes limestone. There's even little microorganisms called diatoms. That's where diatomaceous earth comes from. It's just a whole bunch of little, powder grain of sand size little shells. So that's one way that carbon gets turned back into rock. And then eventually over time, some of these rocks, you know, they erode, they get exposed to air, they have other chemical changes, and another big thing is just getting recycled into new rocks with volcanic activity, spewing out carbon as part of the ash and part of the emissions of a volcano. Or, you know, this can also come from hot springs, thermal vents. There's all kinds of things going on, but this is your slow cycle. It goes from rock to atmosphere and back to rock, basically. You could also kind of put coal in a special category here. Most of your coal was formed very early in the history of the world. So it basically, most of it was formed at a time when plants just started developing woody tissue, and the things that break down woody tissue really hadn't evolved to deteriorate that yet. So that's when you had a bigger buildup of plant material getting fossilized as coal. Methane is also a carbon compound, natural gas, petroleum. They're all ways that carbon got locked up from dead plants and animals a long time ago. But this still happens, but it normally doesn't happen in the quantities that are gonna make those big thick layers of coal that we've been mining for the last few centuries here. See. Okay, I think I covered everything in the slow cycle. The fast cycle, which is the one that most people think about, is where plants, through photosynthesis, take carbon dioxide out of the atmosphere and they create plant tissue and release oxygen. They soak up the carbon and use it as a building block to make sugars, starches, the cellulose, the big long chain carbohydrates that humans can't really digest, but things like cows and some other herbivores can. They have bigger stomachs and ferment them. But you know, the building blocks of a plant are made basically out of the air. And this cycles back into the atmosphere whenever something eats a plant. That's part of the natural cycle. You'll hear people talking about, well, cows give off methane or whatever. Well, if the cows didn't eat the plant would eventually die. Something would eat it, and even if it's a little microbe, what's happening on a cellular level is the same. It's still going to break it down and either create carbon dioxide or it's going to create methane. Those are the two main things. There can be some other little compounds in there, but in the presence of oxygen, normally CO2 is created. In the absence of oxygen, normally methane is created. That's why methane forms in like the bottoms of swamps. They'll call it swamp gas or whatever. And that's why swamps have that sort of smell, because the anaerobic decomposition underneath stagnant water that's blocking off the air. Once the oxygen in the water is exhausted, those little microbes go over to anaerobic digestion of stuff, anaerobic metabolism, and they're creating different byproducts other than CO2. You can't create carbon dioxide if there's no oxygen to make that dioxide part of it. Yeah, in general, that's basically it. The carbon gets photosynthesized, and plants even themselves, they do regular aerobic respiration as well and do produce carbon dioxide. They just give off more oxygen and consume more carbon dioxide during photosynthesis than they are giving off through their metabolism of the sugars they have created. And there's a lot of it. This brings to the next thing, which is kind of the reservoirs. One of the big reservoirs is just plants, the biomass, what carbon is tied up in living things. And that's the thing that everybody's focused on the most. There's also coal and limestone, and there's a certain amount that's just always in the atmosphere and always in the ocean. And, you know, when we're burning coal, and even when you're burning, you know, limestone, other things, you can be giving off, you're taking stuff that was stored in the earth and you're putting it back into the atmosphere. So as far as greenhouse gases and global warming, it's a matter of balance. And what human activity has been doing is shifting the balance. And that's the part that's left out. As I said, people, you know, climate change deniers or whatever the hell you want to call them will sit there and be like, well, you know, cow farts put out methane and whatever. But the thing is, human beings are grossly shifting that balance. We're taking all this that was stored in the earth and putting it out into the atmosphere. Normally the balance, yeah, it kind of, you know, goes back and forth within a range. Normally in the summer when plants are growing, you know, more carbon dioxide is being absorbed by plants. And then during winter, there's less carbon dioxide being absorbed by plants, and there's a shift. There's more carbon dioxide in the atmosphere during the winter than there is during the summer because of this. The plants are taking it out during the summer. They're not taking it out during the winter. For the most part, your animals, and included in what I'm generically calling animals for simplification, is you know, fungus and bacteria and other things that are consuming these plants, whether dead or alive, and cycling that carbon dioxide back into the atmosphere. Little side tangent, just with human dieting, people don't realize that, you know, when you break down fats and sugars, the way they leave your body is through your breath as carbon dioxide. You know, that's the way the metabolism works. Without belaboring the chemistry of the Krebs cycle and all this other stuff and how sugar is made and broken down, and, you know, was it adenosine triphosphate, and all kinds of little things moving around in there, and I think that would just make it too complicated. But in general, you know, carbohydrates, carbon, hydrogen, that's where the name comes from. So you're breaking that sugar down, and you're either taking an, normally, because we only do aerobic respiration, we grab that and we add an oxygen to it as it splits and split it apart. And that's how we get energy back out of it. We turn it back into CO2, we get a little bit of energy. Every time we, you know, that carbon recombines with the oxygen. You know, it's basically like everything in this world wants to be water vapor and carbon dioxide. So something that's put together differently as far as these hydrocarbons, you know, if you've got a little bit of water and a little bit of oxygen, and you can let it go back to wanting to be water and carbon dioxide, then you know, you get a little bit of energy back, because it takes energy to put the carbon dioxide and the oxygen into other hydrocarbon configurations. Plants use the sun's energy to do that in photosynthesis. So you're basically getting the sun's energy back out of it. Yeah, sorry, that's a little bit of a tangent. I just know a lot of people think they kind of like, they sweat off calories or whatever. It's all in your breath. It's really a strange thing. Most of a tree came out of the air. You know, there's some trace minerals and stuff that come out of the ground that needs a little bit of nitrogen to make the proteins. There's proteins in your DNA and things like that. Amino acid, anything that has the word amine or amino in it has nitrogen in there somewhere. But most of a tree is carbon. It's sugar and cellulose and things like that. It's hydrocarbons. And those hydrocarbons are, you know, primarily coming out of the air. You see an oak tree, all of that oak tree came out of the air. Fire is also part of this. Not so much here in the east. In the east, you know, where I live at, most of this area gets about 40 inches of rain a year. It's fairly damp. You know, things tend to decay here. We don't have many forest fires. When stuff falls, it tends to stay damp, gets covered with moss and lichens and stuff, and breaks down and ends up in the soil. Now, these things breaking things down are still giving off CO2. But out west, where they've got problems now, and this is a whole other thing to get into, because normally fire is part of the natural cycle out there every several years, you know, maybe every 3 years, maybe every 5 years. It varies depending on rainfall. There's a lot of different microclimates that make up the West, so you can't blanket say one thing fits all. But in general, places where it is arid, you have regular fires, and all your dead leaves and that just burn off. It's supposed to be a quick little fire that leaves the trees behind. The trees are normally adapted that they are not hurt by these quick, cooler burning fires. And because these things happen regularly, not enough fuel builds up to catch the trees on fire. Fire suppression has actually been one of the things that has exacerbated the fire issues they've got out west, because the fuel has often built up from the fire suppression, so that whenever a forest fire does happen, now it's got enough fuel that it burns hot enough that it actually catches the trees, and it becomes a whole different animal instead of being something that just, you know, it flashes along the ground and burns up some, you know, maybe a few dead twigs, but mostly just, you know, dead leaves, dead herbaceous plant stalks from the previous growing season. Now, you know, instead of the bark protecting these big trees from these fires and that, it's burning the trees, and, you know, it's a whole different animal. I mean, that's a whole other subject I'd like to get into, but that can be its own video, because both the left and the right are right, and both the left and the right are wrong on that subject, and it's just gotten way too political and unscientific. There are multiple causes of that problem. But at any rate, getting back to the carbon cycle, obviously when a fire burns wood and other plant matter, it goes back into carbon dioxide and water vapor normally. So that's the normal thing. There's always a decent amount of carbon in the ocean. The more carbon in the ocean that's absorbed out of the atmosphere when we've got more CO2 in the atmosphere, going back to that long cycle, or slow cycle I should say, the ocean itself starts getting slightly more acidic. And this causes problems with some life forms, especially things that tend to have these carbonate shells. Well, now that the acidity of the water wants to eat away their shells. You know, it's not extreme. It's not like we're going to reach the point where, you know, the ocean's just going to, you know, instantaneously dissolve metal, although it does corrode metal at a much faster rate than you would think it would, even just from the salt in it. But you know, it is a problem. It's starting to affect things. Some of the carbon that's stored in the ocean is stored in the form of you know, living things like coral and other animals that build shells, or I'm not sure you really call coral a shell, but you know, they're building this rock out of this calcium carbonate. And that's another problem with reefs dying off, is, you know, that's something that was taking the carbon out of the water. Now it's not. And some of your carbon is tied up just in the biomass of things like algae in the plankton layer, and some of it's tied up in the sediment at the bottom. Just, you know, microbes, you know, are made out of carbon, and they die and they fall to the bottom. And while things do eat them at the bottom to some extent, there's some that's just, you know, buried in there. Kind of think of the way that like peat builds up in the bottom of a bog. There's just, at the very bottom of the ocean, there's not that much oxygen and not that much heat, and just, you know, it's not breaking down as fast as it's accumulating. Think that covers most of it, but like I said, it's a balance. The majority of the stuff is just cycling through and cycling through and cycling through, and certain things will affect that balance. One thing that people don't seem to take into account is water is also a greenhouse gas. But water tends to be fairly constant. As long as the temperature is constant, you're going to have a certain ratio of water vapor in the atmosphere and a certain amount of water that is locked up as either ice or liquid water. But as it gets warmer, you're releasing more water from ice caps, and also more water evaporates into the atmosphere. And the more water in the atmosphere, the more it shifts things towards being warm. So there's a lot of interplaying things. It's complicated, you know, and scientists are running models and that, but there's a lot of moving parts. And there's a lot of things that are, you know, they're just good estimates. I mean, we don't have exact down to the you know, 10 decimal point quantities on anything in the world, really, or very few things. So, you know, we can predict things within a certain range, but we can't predict things, you know, precise down to that little decimal point. And that's where, you know, people that deny climate change or deny, you know, any of this stuff start trying to chip away at it. But I mean, it's like predicting the weather. You might, just because you can't tell exactly what spot on the beach a hurricane is going to land because there's so many variables, doesn't mean that the hurricane doesn't exist. It's the same thing with climate change. Just because, you know, a little detail here and a little detail there is a little bit fuzzy on the predictability, doesn't mean that the overall concept is a myth. People like to go there, you know, unless you can say that it's going to go up by, you know, this many decimals of a degree for you know, every time they start their car or whatever, they think, oh, not scientific. It's like, yeah. But another thing related to this is just the whole thing with planting trees. Seedlings obviously don't have as much carbon stored in them as large trees. a lot of times, just like climate change being a major issue is somehow, take the wildfires going on right now. It's seen as being the only cause. It's not the only cause. If you think it's the only cause, you got your head buried in the sand. It is a cause. To deny that it is a cause is also false. But as far as a solution to carbon emissions, planting trees isn't necessarily, this little silver bullet that's going to cure it, because in a lot of cases, you're going out there planting trees to replace bigger trees that were cut down. So you're not necessarily gaining anything. There are, charities out there, and it is a good thing to plant a tree to replace one that was taken out. But sometimes I really wonder about some of these things, because it's like, well, you're planting a tree where it's just been logged. Shouldn't the logging company be planting another tree just because they want to come back in 20 years or 30 years and cut that tree down? You're basically, it's like, because a lot of these forest plantations, they're raising trees, a select variety of tree, as if it's a crop, like corn or soybeans or anything else. And it's like, some of these things, I think we're just, donating money to grow corn for somebody else. You're not really necessarily gaining on the problem. It's more complex, but I understand that people want to do something. They want to make a difference. They don't always look farther than throwing money at something to alleviate their conscience. Unfortunately, they don't really do the homework on where is this money going, what is it doing, and is it really accomplishing anything. Preserving mature forests probably has a bigger impact than planting trees in these places that are being logged. Although planting trees in these places that are being logged does have its own benefit, the planted trees, depending on what species they are, might not, they won't have the same biodiversity. And like I said, you're basically, some of these forests are basically like a cornfield, just constantly being recycled as a cash crop, and it's a different thing. And it is doing something, I guess. It's better than not replanting the trees and then going down and cutting more virgin forest, but it's not the impact that people think it is all the time. I can make a whole video on that by itself. Not wanting to get off on too many tangents here, but I'll put a link in. It's to NASA. They've got a good explanation of the carbon cycle. I know that some people think that NASA is, a conspiracy run by our alien lizard overlords or whatever the hell, but this is real. You can prove it to yourself. There's a guy that did an experiment a long time ago. I can't remember the guy's name, but he basically planted a clipping of a pine tree, and he weighed he weighed the soil, he weighed the branch, he weighed the water he was giving it, and then at the end of it all, after a year, he took it all apart and he weighed the tree, and he weighed all the components, and he figured out that the carbon, most of what was making up the tree that grew from that cutting had to come from the air, because it exceeded the other inputs. So, but at any rate, I'm gonna leave it there, and I'll see you on the next one. Well, I hope you found that video informative. Hopefully it made you think, and please click the like button and subscribe if you haven't done that already, and check out the video that should be appearing somewhere around me here, and I hope to see you on the next one. Thanks.